4 panelists. I think we're waiting on one more to discuss how additive manufacturing, the supply chain, is moving into production over these last couple of years at an accelerated pace. First, I would like to introduce Alyssa Welch. She is the Global Marketing Manager at AMT Post Pro. AMT is a global additive manufacturing technology company that is focused on streamlining the additive manufacturing workflow through its suite of post-process equipment. And they're really trying to take equipment and move it from a manual, costly environment to a high volume automated process. Alyssa, I've worked with now for the past year, and she really is a go-getter and open to taking on any challenge that comes her way. Next up, I would like to introduce Guayente Sanmartin. She is the General Manager and Global Head of HP's MJF business. And she's responsible for overseeing all the technology, operations, commercial, and new business incubation activities. HP provides robust series of 3D printing equipment that's used throughout the world, both in prototyping and production applications. Guayente inspired me during a visit she had. She was bringing her daughter to a prestigious university here in the United States. And, she helped show that the future of additive manufacturing is now, and that we have the capability to advance AM at an accelerated pace given the changing environment. And then next up, I would like to introduce Tracy Brent. She's the president and COO of the Technology House. It's a contract manufacturing company located in Ohio in the United States. And we're primarily focused on aerospace and defense, medical, and industrial applications. And we do a wide array of additive manufacturing processes we have in-house: injection molding, cast urethane, and machining. Tracy is one that never meets a problem that she can't solve. And then last but certainly not least is Carrie Braun. She's an optomechanical engineer at L3Harris. L3Harris is an end customer of additive technology focused on aerospace and defense industry. Carrie is in the photonics and quantum sciences research and development division. And I don't know what else to say about that because that's impressive enough. So we have a great panel discussion, again, to talk about additive manufacturing, the supply chain. As you've seen other presentations today, it's a very dynamic, changing, and there's been a lot of disruptions in the past 2 years. So with that, my leading question for the panel is, lives were changed at the beginning of 2020, as we can see from the video that we had. Please provide an overview of what's changed in both the general manufacturing supply chain and also within the additive supply chain over the past couple of years. Tracy, would you like to lead us off?
Sure. 2020 was a very, all of a sudden everything shuts down and all of your normal production parts you do come to a screeching halt. So in the additive industry, it was amazing how fast they picked up the ball, especially in the medical world, and were able to start designing, again, as you saw in the video, designing swabs and headbands and apparatuses for hospitals that were needed. And I think what really happened was the additive industry got the push it needed that for years we've been trying to do, of the heads of hospitals and companies to say, yes, let's do this. And this is the time to do it because we can get it pushed through and approved. We weren't before, we were too afraid to do it before. We just didn't want to take the time to figure out how to do it before. It was a need. And so you got the people that needed to get things approved to push things through in a very fast way. And as we're seeing now, it's here to stay because they see it works.
Yeah, I agree with that. Definitely. Since the beginning of the start of the pandemic, you see, or we immediately saw the additive industry step in to fill in those gaps of the supply chain shortages all across the globe. And I think that despite all of the negatives that came with COVID, this definitely opened up the door to numerous additive applications. And I think that something that the pandemic really did prove was all of the mass capabilities that additive has to offer, and that 3D printing really does have an influential role in the manufacturing supply chain.
I would just add that I know, like many, as we have seen the video, and everybody is seeing, it opened up the eyes for big CEOs of companies to really rethink not only the manufacturing processes, but also the way the supply chain is structured. Today, I was reading an article from McKinsey that was saying that the agenda of 2022 for the CEO is going to be an operational agenda, meaning that the CEOs today, one of their main jobs, is going to be to rethink everything related to the supply chain, and that they could even lose 42% of their profit in the next 10 years if they don't take actions. So that I think it's this is as we are all saying, it was the time for now. This is true. You need to change.
Thank you. And, as the disruption happened within the material and labor supply chain within traditional manufacturing, additive, from our experience, has been able to keep up. There hasn't been as material issues in getting your material through additive manufacturing. Why is that? Why is it so difficult to get material for injection molding, machining, sheet metal, etc., but additive has been able to keep up their supply? Guayente, will you lead this one?
On this thing, I think there has been also shortages, and I have been checking, for the different materials in the market. It's true that the additive manufacturing materials have been less affected, but they have been affected as the rest of materials due to shortages of employees, as well as certain, parts of the world from shipping problems, as well as basic material. There has been, it's true, as you said, that they have been not that big as the rest. And the main reason, I think, has been additive manufacturing. It's a segment, especially for materials that have a higher margin. It's lower volume, compared to injection molding. So if you have to protect one thing that you want for sure to supply, you usually protect those that are strategic investment, that where you have more revenue, and like the volumes are smaller. So I think that has been one of the reasons, on the less shortages that compared to other parts.
Yeah, I would agree. Actually, as my picture changes, and can you all hear me?
Yes.
Yes, we can hear you.
Perfect. All right. We'll just watch as the picture changes. But I also want to kind of roll in with question one is, as the end user, we're more of, L3Harris is more of a, I guess, almost like boutique or like one-off. But with that, we're usually going through the design cycle much more frequently. And a big change between now for, in terms of also for additive and traditional machining, is design engineers are actually taking into account in their design process about availability. So we actually see almost like 2x, 3x times for machined or fabricated parts. And also we're even asking the question of, does the print shop have this? What's the lead time for any of our service bureaus, and having to take that into account as we're trying to figure out what materials to use and how to best be able to meet our customers' needs. Before, we just assumed it would always be there. And that's one big change I've seen with COVID is design engineers from the very beginning are having to ask the question of, will it be here?
Wow. No, that's very insightful for what is happening in the environment today. because
Can
you don't
I
know if it's going to be there.
just chime in on this subject also? They, I know that a lot of our customers are medical, so they'll call out the specific plastic and brand of plastic. And I think what this has taught a lot of our end users is that they have to dual source things, and maybe not even just dual source materials. Some of our customers have even dual sourced processes. So if they were traditionally mold injection, they will also do HP manufacturing. So it's not just, so if one industry's hit, they can switch processes also. So they validate both upfront.
So that leads us into some of the success stories, because you mentioned within the supply chain, medical customers are starting to validate multiple processes. So the next question for you is, provide us a success story on how AM has helped overcome those barriers in traditional manufacturing. What advantages does AM have over some of those traditional manufacturing processes to make it appealing to our end use customers? Carrie, would you want to lead us off on this one?
Yeah, sure. I would really say that it really excited our management, I would say, here. We were able to see all these success stories about how quickly the medical community was able to adopt and figure out how to use additive and be agile and work that way, and having these success stories, right? You know, defense and medical, right? That has this huge barriers to be able to have risk, right? You know, it makes sense. And our management got so excited and said, we want a piece of this. We're able to design and iterate so quickly. Imagine if we're able to put that in our own system. So seeing all these success stories, you know, everywhere that we're able to quickly use additive, I think it was really pushed forward and brought that recognition of, wow, this is something that we should figure out how to use in more places, which, you know, it was always kind of a nice thought, but now it's very much at the front of everyone's mind, and it's great to see.
If I look at an NHP, you know, like we're focusing mainly on the four main segments, one being healthcare, the other consumer goods, industrial and mobility, and we have seen across each, you know, like different successes, no, of especially, for example, on automotive, like companies have had, the big brands have always, you know, have been for a long time with some 3D machines, but they were being used there, you know, only for some proto, and now they are seriously considering, you know, to move parts, especially for those parts that are, you know, like for the electrical vehicle. So this is, you know, like a lot of successes. On the consumer goods, I can tell you that like we have been working a lot with L'Oreal, you know, and for their manufacturing lines on how to change, you know, the what they call the packs, you know, enabling the L'Oreal, you know, to change the amount of products that were being built at a time. They have been seriously, you know, like deploying this into their manufacturing line. So it's more like what we call the application on G-stand fixtures. And it has helped them, you know, like save 33% on the cost, you know, and like save 66% of the time that was required, you know, for this before. So it's just like to name a few, but like the good thing is like big brands are starting, you know, to consider. Still, it'll take a while, and we'll talk about it on why, no, to fully explode, but the potential is huge.
Yeah, I agree. Kind of to echo that, you know, one of the main advantages that I think Additive has to offer is the mass customization and the ability to quickly iterate designs and manufacture on demand in any part of the world. And kind of bringing back the whole COVID aspect of that, a great example of this is the nasal swabs that we saw produced in response to COVID in the supply chain. So you have companies like Zigzag that immediately at the start of the pandemic started utilizing their fleet of HP technology combined with AMT's post-pro chemical vapor smoothing to produce high volumes of these nasal swabs and supply all of the hospitals around Europe. And they were able to pass the necessary tests for medical approval. And all of this happened in a matter of weeks and months and was enabled by additive, to where traditional methods just wouldn't allow that.
Tracy, do you have anything to add for this question?
No, I think they pretty much covered it.
You have a lot of successes in Technology House, so you can share many.
There are. So, as you could see, there was a lot of success stories within the additive space these last 2 years, propelling that growth and really showing from, a global scale. I know here at the Technology House in 2020, we had probably over 60-70% of our additive machines doing production activities, which then dropped off to once the market was flooded with face shields, nasal swabs, et cetera, back to more of the prototyping phase. But it showed and accelerated the growth. I think, Guayente, you mentioned, to upper level management, and them seeing, and Carrie, you may have mentioned as well, seeing the possibilities to drive it forward. But, although there's a lot of advantages to AM, what are some of the challenges that still exist for AM to continue that adoption, to accelerating that production?
I can take that one. I think from all the success stories, I think we've closed the gap. But the biggest thing is AM has traditionally been a prototype or low volume production or consumer product where there aren't as many FDA approvals and audit approvals and such. And it's an eye-opener when you're starting to validate machines, that all the stuff that medical and aerospace need for lot control, material, knowing what exactly is touching their parts, the humidity control, temperature control, lot numbers, and especially with a lot of the additive processes, you mix lots of material together as you're making products. So I think it's also helped us as manufacturers push back onto the additive machine makers to say, hey, how do we figure this stuff out so we can validate these processes? And since they've started doing medical stuff, they see why it needs to be done. So I think there's some more work to still do, but we've come a long way just in the past year of what we were last year and why we couldn't use it for a lot of medical aspects to today. A lot of it is going that way, and we figured out how to lot control and material control these processes.
I would add that, I see the challenges in 3 buckets. The first bucket is what I call the customer challenge. And then there are several, as we said, how knowledgeable, the company, the engineers are, and how much the CEOs are really asking their teams, to move into these new technologies. So that and also the capacity for the companies to know which parts are very good for additive manufacturing and not, and selecting those applications, for the type of geometry, for the design savings, for, the uniqueness, the personalization. So selecting those parts, is the first challenge. And as you said, Tracy, is this move to production, not only staying in prototype. And that's what I call, the customer challenges. Then I call what is called the part challenge, and is related to the technology. Okay, so still we need to continue, all of us working on the technology to ensure that we can meet, all the KPI dimensions and characteristics of the part. We need to continue bringing costs down. We need to evolve, the materials and and what I call the part repeatability. So the systems today, there are few of them, that can produce parts, in production, but that the machines can produce the part once and again. And the third challenge is what I call the industrialization challenge. Printing a part is just one part of the process, and like our friend Alyssa and others will know, like, but then you need to produce a product out of this part printed. There is a full industrialization, and that's like all the automation on the digital and the physical aspect, like is one thing that like needs to be rebuilt for AM. So a lot of challenges, still that we have, but as I said, like there are many companies and few of us were working on them to solve them.
Yep, I agree with that. In my opinion, surface quality is one of the main challenges in enabling additive to be used for end-use part production, and being able to have that surface quality that one can meet the standards for applications such as medical or automotive or aerospace, and are able to compete with their traditionally manufactured counterparts. As you mentioned, that raw state of the 3D printed part off the printer has surface imperfections that don't meet these standards. So you need technologies and post-processing to completely finish these parts and make them more durable and able to pass the necessary tests to be ready for end use.
And I love, by the way, like in the chat there are comments, so I would love, to get other challenges, that like our attendees are hitting. So like it would be great. Just add, I see Carol, thank you for adding more challenges. I know we agree with some of them, and consumer goods, there may be parts that are not good, for additive manufacturing. And I think that's, again, I go back to the customer challenge, selecting those parts that have a unique value, that where additive manufacturing will bring the cost, the material, the sustainability that you cannot get with other technologies, I think is the first step. So keep adding.
And one thing I think it too is kind of going to the customer again is educating the engineers as well as everybody else about what it takes for it. Actually making additive manufacturing an actual tool, right? You need to be thinking about it from the very beginning, right? And the more educated our engineers or design engineers are about how, not only how to design for it, but the limitations to it, right? Just like any other manufacturing method helps so much more in terms of being able to have it be utilized more, right? It's not taking something traditionally machined and replaced by additive, but have it be something in their process as they design it in the very beginning. And that just comes and informs more as we educate people. Mm-hmm. I think that's a major, major hurdle and informs the rest of it to push it forward.
It was mentioned on being able to the traceability, lot control, and highly regulated industries. What are some of the machine manufacturers doing? I know Alyssa AMT is going through trying to help automate these processes. What is AMT doing to help on that traceability front in order to track those parts throughout the process?
So that end use parts, for them to be enabled to be used in different applications, that requires, if it's one part being used for medical, okay, that one particular part needs to undergo the series of tests. We can't just say every single part that goes through our machine is 100%, passes the tests for those. But one thing we are doing on our side is we are gathering this data. I know right now we have a bunch of data on tests that we've passed for like TPU, PA11, PA12, various materials with different printing technologies. And so from our side, we're gathering that data to help validate the process and open the doors for it to be used in more applications.
And Guayente, I know HP is doing a lot on the software front. Is that, from your perspective, is that helping with the traceability of the product throughout the entire system?
Yeah, I think it does. As I told you, like there are different parts, like on the challenges, and there will be software assets that we need to develop into the part repeatability and into the industrialization of the part, which include this one. So it's a fundamental. No, I think that when we think about an application, we need to think what are the different assets, from materials, software, hardware, services that we need to put together in order to deliver, this part. So yeah, very important.
And that leads me into my next question is, how will the AMT community overcome these challenges? Not only did I hear discussing non-traceability, but cost as a challenge, and, amongst the others you mentioned.
Was that for AMT? Sorry.
For AMT, yep.
So one way that we're helping reduce overall cost per part, we just launched our next generation chemical vapor smoothing technology, the SF series, which is a more higher throughput machine, and it uses less consumables, which all of that overall reduces the overall cost per part. You're going from traditional methods of manual post-processing to now being able to finish an entire batch of parts in the matter of 90 to 120 minutes. And so in overall reducing the cost per part, that's through automation, is what we're doing.
Great. What else does the AM industry have to do in order to accelerate adoption?
I think it's to keep doing what we've made progress on this year. Don't let it slow down. Keep the heads of companies, as in the HPs of the world, and the customers, the medical customers, going full throttle and not slide back into traditional manufacturing. To all the new products, at least have it a visual showing that we can do this. We can make a nice looking part that can go through a hospital system, and keep pushing the not materials, but the traceability with the additive processes. Again, we've learned a lot this year, and everything that we've learned, we've been working with the AM groups of the world to say this is what we need. Yet we're also pushing on our customers, saying, why do you need this? Is it just because you've always had it, or is it there for a reason, or are you just somebody put it there for the fun of it to make it more challenging for us, and we don't need this? Or what is the information you really need to get out of this to see if we can get around it some other way with the technologies we have? And again, when you mold injected something, you made a tool. If there were any changes to it, you would do an ECO, and it would take 16 weeks. The challenge with, again, going back to the AM, is it was traditionally a prototype process. So as our prototype minds work, oh, I want this change, we're ready just to do it. But we also have to realize that when you're working with the medical and aerospace customers of the world, you can't just do it. You still have to go through some of the hoops that you did with traditional. It's gonna go faster, but you still have to do your validated runs. You have to run tests and submit ECOs the way you would with a traditional tool. The good is really cheaper. You still have to run the test, and it's going to be some kind of NRE, but it's not going to be as much as doing this, changing the tool, and ooh, does it work? Oh, it kind of works. You can still do a couple of iterations if you need slight tweaks on it. But it's just to dial up the speed of the end customer and still dial down the speed of the people that are used to working in AM, and meet somewhere in the middle ground.
Yeah, that's really encouraging, right? Like just the traceability coming along, because I always think of, we're doing our best to understand the processing, being able to qualify a machine and the material as well. Because for an aerospace engineer, they'll pull up volume 3 of a stack of a 3-ring binder will tell you all about cold rolled steel, right? I can tell you all about what's going to happen with all the material process based off of, thousands of coupons, right? It seems so boring, but it's wonderfully boring. Like, because it's just, we have that traceability, we know what it's going on and how it's going to react. And we're starting to get there. I really think so. We also have a lot of work being done by the American Standards of ASTM and testing methods, and as well as ASME, right, for design, so that we're out ahead of it, as well as, able to do that in production as well. So I think we have, we're going in the right direction. I think COVID turbocharged a lot of the things we've been trying to do for a long time. That's the right way to say it.
And I think we'll need to continue, as I said, with these 3 pillars that I mentioned before. On the customer, I think we need to be teach and from a customer perspective, learn again what are the specific parts that have a benefit, by being done on additive manufacturing. Second, I think we need to move our devices to be real production devices, not just prototyping, which will mean increase the system repeatability and increase materials. And I think the third thing, is in order to have mass customization, we need all the software, end to end. We need to facilitate the digital and the physical workflow, to help them be automated. So that's the efforts, that we need to keep pushing.
Great. So as I oversee the finance and accounting at our company, I have to throw in a little finance industry thing. But in the finance world, there's really a push for sustainable investing. So, or it's called ESG, environmental, social, and governance. And, people want to invest in companies that they believe in, that fit their value system. How is the 3D printing contributing to achieving sustainability or, different climate change goals? Guayente, do you want to lead us off on this one?
Well, I can tell you first, I think this is one question that for HP as a company is very important, HP has decided, has a sustainability goals, and we have been, in fact, when we think about sustainability, we think about 3 aspects, what is climate change, the other is human rights, and the other is more linked to the community that we call digital equity. And despite you asked, for the climate, let me tell you that as part of the sustainability, and we are in an event full of fantastic women, I think HP is the first technology company that has made a claim that they want to have 50% of the leadership, by 2030 to be women, so that's the first, on the second, of course, not related to climate action, HP has decided to achieve net zero greenhouse gas emission across all HP value chain by 2040, reach carbon neutrality by the HP operations by 2025. So it's just around the corner. So that and I think just from a 3D point of view, not our technology, which is using powder that you can recycle, not like others, and all these programs, not that we have the Take Back program, I think are just a few things. So I do believe this is not only the financial point of view, as you say, Lauren, people want to invest on those companies, is the right thing to do, and only companies that have this purpose, that is truly authentic, purpose to help on the society and the world will survive. So that's I encourage everyone to think what are the sustainable goals and make actions on them.
Yeah, definitely want to help our environment. And it's great because like you mentioned, HP with the recycling of the material is huge and makes the operations aspect more efficient as well. So no, it's very important there. And then our last question is, what is the future of 3D printing? We've seen an acceleration. As Tracy mentioned, we don't want it to stop. The adoption has been significant. It's been proven out. The FDA's done emergency acceptance of various product these last couple of years. What is the future?
I'll jump in on this one. I mean, I think the future of 3D printing is right now. I mean, we're starting to see an immediate and positive shift from low volume prototyping to now more high volume end use applications. And I think, you know, going back again, the past couple of years, everything that we've accomplished and proven through COVID has really enabled the industry to leap forward. And I think that in order for the industry to gain greater adoption of additive for more applications, it'll require all of the everyone in the additive ecosystem to all come together. So it's not just about the materials, it's not just about the printers, it's about the design, the software, the materials, the printers, and the post-processing solutions that really drive these high-value products that enable the mass adoption of additive.
I think the future, if we can come up with post-processing solutions, that will help tremendous push for things to either switch or lessen traditional manufacturing to go to AM, because with getting the AMT, we have switched processes from traditional processes, molding processes, to HP and then AMT. And there are parts that we were getting out, we were struggling to get out like 30 pieces a week because of the finishing on them and the way they looked, to now our customer actually is like, whoa, you can slow down now because you are producing more than like our whole order in a month. So we are able to just, fill a bucket of HP on, and then the same amount can go into the AMT process. And they look better than the molding process was, just because of the size and thickness of the parts. So I think with the post-processing on board and trying to work on the labor part of the additive manufacturing process, the better and better we will be able to get. And that will also start to help bring the cost down, because the labor costs will go down of the parts.
And I think what is the future? I think 3D, and like it has already been told many times, but 3D is one of the few technologies that is gonna reshape industries, no? And like if we look, 3D has the capacity to transform ecosystems, no, and workflows, no, and you can see, how 3D is helping on the healthcare, like distributing, from aligners directly to the consumer. So it's changing like supply chains, how it's changing the footwear industries, and how it's changing the even more the packaging, like for molded folded mold fiber molded, like in order to create sustainable packaging. So I think like the 3D is meant to be a technology to transform industries, and we will see more and more more of those. I'm watching closely, many startups, that they take a problem in an industry and they develop the solution and the full ecosystem, and it's amazing, So this is meant to transform the work and make advancements from a world perspective.
Great. Carrie, any last comments? I saw you're going in and out there, so if you can hear us.
Yeah, a little bit. Well, so one other perspective too is it's we're able to see AM being used more as a production tool, but we're also seeing, especially that, right now we have a lot of really great materials. We're pushing the boundaries there. We're having a lot of good science being done. But one thing that is, I don't think really talked about, but one thing I'm really noticing is that the optical and photonics community is taking notice of additive. A lot of major conferences. The entire track is devoted to what research is being done for optics to be able to do better resolution, to be able to get smaller parts, to be able to have better granularity. And I think that's something that we're in scan packs, especially, oh my gosh, of really seeing, I think we're going to see in the next, 5-10 years, really take off and be able to, not even be able to imagine it, just significantly improve where we are with a lot of key things. So that was just something for the future Additive I think isn't really talked about. We don't really know yet, but I think it's going to get really big very soon.
Great. Well, thank you, everyone. I think we're out of time now.
Yeah, that was a great discussion. Thank you all. You're all intriguing and well-informed women. Thanks so much for joining us at the conference. And we are going to head back to the main floor for some networking. So if anybody in our audience wants to catch up with these wonderful ladies, then please meet us back on the networking floor for more. Thank you so much.